So let's go ahead and going over the practice exam. So I'm going to go ahead and write this on the board just in case anybody misses it. But I don't know why people missed this for the exam this morning, but you are allowed one sheet of notes, which I've mentioned before, I think. But you're allowed one sheet front and back of notes to bring in.
Any specific paper size?
I don't care. I mean, like a letter or A4. Okay, so something that's the standard size. Standard size. As opposed, I know that also Japan has its own slightly off. If it looks like a regular sheet of paper, it's fine. All right. So answer the questions in spaces provided. Please note there are no intentional errors on the exam, except in the questions that ask you to correct an error, right? Otherwise, so there's no trick questions. In other words, there's no like, oh, this works. This doesn't work because it's wrong, right? There's nothing like that unless I actually ask you to do that. Otherwise, I'm making you guys be super paranoid, and that sucks. So I give you the breakdown of points on here and at the bottom of the page. Like over here, this page is worth 0 points because it has stuff for you. Over here, it has it says this page is worth 3 points and stuff. It's exactly like the practice exam that I gave for the Python class, but the actual exam itself is actually quite different from the Python exam. So, all right. So, first off, computer science is the study of computers. True or false? False. It is the study of algorithms. That is your one answer. So that is your one sentence definition for computer science. Computer science is the study of algorithms. Alan Turing. So by the way, where does the word algorithm come from?
Persian guy.
The Persian guy, right? Who I mentioned.
About it here, though.
Right, we haven't. I was asking if people knew. So it comes from this guy, Muhammad ibn Musa al-Khwarizmi, who I probably butchered his name. He wrote a book on how to deal with these newfangled numbers that came out of India that worked in base 10. And his book was called Al-Jaber, was one of the words in the title. So he wrote the first algebra book. He also wrote a bunch of other stuff on how to do, so his name, which was when it was Latinized to Al-Ghamidi, Al-Khwarizmi got Latinized to Al-Ghamidi. He got the term algorithm, and algorithm came from it. So it's named after this Persian mathematician. Okay, that might be on the exam. Actually, totally is on the exam, so you should probably know that term. Okay, Alan Turing is often considered to be the first programmer. Yes or no? No, he is not. In fact, it's answered by the next question. Who is Ada Lovelace, and why is she an important figure? She was the first programmer, yeah. Okay, so Alan Turing is often considered to be the first programmer. No, he's considered the father of computer science because he created a mathematical basis for what a computer is. So that was a big thing. So then you're on the exam. You have 10 questions that look like this. Okay? And I'm asking you to evaluate them into expressions. So what do these things evaluate to in Java? So the question is, do you remember your order of operations? Okay? And, I don't like those internet fights where basically people say 9 out of 10 people can't do basic math, and it's got some weird thing with whether or not, if it's a division symbol, right, or this, is there what order are you supposed to do things in, right? You can actually find different opinions on order of operations in old math books to support your opinions. So my answer is always, it's whatever you plug into the computer that's right. So 2 times 3 is 6, divided by 6, so that's 1. 1 times 100 is 100, right? So all the math here, while it might look to be hard, it's never actually going to be hard. Big numbers typically get multiplied by 1 or 0. Right? Notice how that just all reduced to 1 and became 100. 1 mod 2 plus 3 mod 2. Remember, modular arithmetic is something you're definitely going to need to know. So 1 mod 2 is 1 divided by 2. The remainder of that is 1. 3 divided by the remainder of 2. Sorry, 3 divided by 2. The remainder of that is 1. So you end up with 2. Negative 11 plus, sorry, negative 1 plus negative 10.5 is a negative 11.5. So nothing hard there. Just remember that negative numbers and floats combine with each other. 4 plus 5 minus 3 times 2. So we don't do 9 minus 3. So we don't get 9 minus 3, which gets us 6 times 2. We don't get 12, right? You have to do order of operations, which is 3 times 2, which is 6. And then it becomes 4 plus 3, sorry, 4 plus 5, which is 9, minus 6, which gives you 3. Okay, again, order of operations here. We've got some big number over here, but we're multiplying it by 0, so that doesn't matter, right? So it's 0 minus 1.0, which gives us negative 1.0. Again, over here, this is standard order of operations stuff. 8 minus 20 gives us negative 12. So here, another thing is just making sure you remember division. How does division work? 7 divided by 3 yields 2. 2 plus, so this is 2 plus 6. So that gives you 8. 4 mod 2. 4 divided by 2, the remainder of that is 0. Times 3, so that gives you 0. 0. Big number divided by an even bigger number. 0. Right? That's 0. Okay? And then this class question actually I've never gone over, and that's perfectly fine because now is the perfect time to come up with that. It is actually scientific notation, which is perfectly acceptable as in almost every programming language. So this is 10 times 10 to the first power, which is 100.0. It almost never gets used, but I figure I should show it to you. It works exactly like you think it would. The next section after that is 5 points on true and false, evaluating true and false statements. All right? This one is actually slightly different. So, true or 3 is equal to 2. Well, true or false, right? That produces the true or false. And true or false is true. So this first question is true. Not false. So what is not false? Yeah. Okay. And then we just simply go, again, you work from the inner parentheses to the outer parentheses. 4 is less than 2. So that's false, right? Then you have the not operator. So false becomes true. And 3 less than 10. That's true. So you have true on the left. You have true on the right. And them together, so it's all true. Now this one's actually nasty enough that this is an example of really nasty ones. So we've got 32 divided by 8 and 32.0 divided by 8. Okay? So one is 4 and the other one's 4.0. And are they not equal to each other? So let's find out if they're equal to each other first. So this one's actually tough. But the good news is if you don't know, you got a 50-50 shot of getting it right. So now remember what happens when we are dealing with when we have an integer on one side and a double on the other side. The integer gets converted to a double. So 4 would get converted to 4.0 before any comparison happened. So 4.0 would equal 4.0. So that would be true if we had an equal double equals here. But since we don't have a double equals here, this becomes false. All right, and this one, again, here what you want to do is you'll actually want to use, the fact that you have a pen rather than trying to do it in your head, right? So let's expand this out, right? And I'll represent the whole idea of crossing it out. So you've got true and that doesn't matter. Doesn't matter what's there. You have true or something else. But once you have a true, you can go, okay, one side of the or was true, so the whole thing was true. Then you have an and on this side. Okay, so now we have false or true. Again, same thing over here. So the false or true can be replaced with a true. But we see a not over here, a not true, right? Which means we will replace the whole thing with a false. Okay, so now it's true and false, which reduces to false, right? So this entire inner parentheses thing is false. And then we have a not. A not false will flip it to true, so this answer is true. All right, so for the next two questions, we get to assume that x and y already exist. Let's write an if statement that checks if x is a multiple of y, right? That means that x can be divided by y cleanly, right? And we do that with a modulo statement. So the answer for that, so if x can be divided by y, if x is a multiple of y, if x mod y equals 0, that's all we need to do, right? If x divided by y, if x1 is divided by y, its remainder is 0, then that checks if x is a multiple of y, right? It's only a multiple if it can be evenly divided, which means that if you mod it by that number. Again, as I mentioned, the practice exam is longer and harder than the actual exam. So it's a good test for the actual exam. So write an if statement that checks if either x or y is even and the other one is odd. So you check to see if one is even and the other one is odd. So one way to do this is if x, well, we need to check if x is even. X mod 2 equals 0. And y mod 2 equals 1, right? That would mean that y is odd. So that's one possibility. Or, so that's one way this could be true. The other way this could be true is by doing if x is odd and y is even. Everybody see that? How this one works or no? So here what we've written, right, we're checking to see if x is even and y is odd, or y is odd and x is even. I'm sorry, if x is even and y is odd, or x is odd and y is even. So here this checks the first case where one is even, the first is even and the other one's odd, or the first is odd and the other is even. All right. So, what's the output of this? So now we've got, let's see. Here are a lot of for loops. I like giving you for loops and telling you to write for loops or to have one or to figure out what a for loop is. So, for int I is equal to 0, I is less than 10, I plus plus. If I mod 3 is equal to 1, system.out.println I. So let's figure out what the values of I are going to be. The values of I are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then the other, and then I mod 3. Well, what is this value when you mod it by 3? It's going to be 0. I mod 3 is 1. 2 mod 3 is 2. 3 mod 3 is 0, right? There's no remainder there. And then it repeats over, right? The remainder of 4 after it's divided by 3 is 1. The remainder of 5 after it's divided by 3 is 2. The remainder of 6 after it's divided by 3, there's no remainder because it's evenly divided. 7 is 1 more than 6, so it makes sense that there's a remainder of 1. 8 is 2 more than 6, so it makes sense there's a remainder of 2. And 9 is cleanly divisible. Now, why did I do that? Well, because the if statement. We only want to print out if I mod 3 is equal to 1. Now, if you make a mistake like this on the exam where because when I typically you see 0 here, right? If you just accidentally read this as 0 and wrote down 0, 3, 6, that's what I consider like a point off, because you got the general idea, you just made a basic reading error. But the answer we want there, because it's a print statement, not a print line statement, is 1, 4, 7. All the things there when you mod by 1. Okay. Convert the following while loop into a for loop. So basically write a for loop that does the same thing as this loop. Int I is equal to 2. I is greater than, right? So we need so a for loop, if you remember, has the precondition, the postcondition, sorry, it has the initialization, the condition, and the update statement. So we would just simply write, well, which is the initialization? Int I is equal to 2. What are we checking? I is greater than, while I is greater than 0. What do we do? What happens to I at the end of every loop? We subtract 1 from I. And what do we do every loop? That's what goes in the body. We print out an exclamation point. Okay. Here's a good one. What is wrong with this loop? I is equal to 0, while I is less than 10, print out I. It works, right? It compiles and runs. Obviously, nothing wrong with it. But I'm asking what's wrong with this loop, so there's something wrong with it. Any suggestions? What happens if you were to run this? What would get printed out? What? An infinite amount of zeros, right? I is equal to 0, while 0 is less than 10, print out 0. And we don't change it away from 0. It's always 0. So it's an infinite loop, right? We probably wanted to do something like I++ at the end. Write a nested for loop that prints out the following: 10, 8, 6, 4, 2, 8, 6, 4, 2, 6, 4, 2, 4, 2, 2. And I've got a lot of practice problems in the back, which are attached for you to work on for that, because there's definitely going to be one of those on the exam. All right, so how do I do this? Well, first thing I need to do is print out however many rows up there are, right? 4, so how many rows are there? There's 5 rows. So 4 int row is equal to, and we have 5 rows, right? I is less than 5, I++, and there's multiple ways to do this, by the way. I'm just simply doing it like the way I would suggest you trying to figure it out. Okay. And then in each row, on the first row, I print out 5 different numbers. On the second row, I print out 4 different numbers, then 3, then 2, then 1. So I need another for loop. 4 int I is equal to, so what do the numbers start at? They start at 10, right? And right now, actually, you know what? That other part is hard, the whole figuring out what the values are. So right now, I'll just aim to do 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, right? We'll just print out a 10 instead of all those numbers, right? Or something. I'll just print out 10 numbers. Don't even care what they are. I'll put SOUT there, which you can totally use on the exam, right? And then so I want to print out this number. How many of these numbers do I want? Actually, yes. How many of these numbers do I want? Well, I want 5 on the first one. I want 4 on the second one. I want 3, then 2, then 1, right? So that means like I want 5 minus the current row that I'm on, because on this first row, I'll have 5, then 4, then 3, then 2, then 1. Make sense? So how do I print out a value here? Then, well, again, I can use some subtraction over here instead of addition, which is kind of the reverse way of thinking about it, but it can work. I'll show you the other way to kind of go about this. But So now I need to print out the actual value there. So that would probably be 10. On the first one, I'd want to do 10, 8. Yeah, this one's tough, isn't it? So 10 minus I, that'll give me 10, 8, 6, 5, 4, 2. Then 8, 6, 4, 2, then 6, 4, 2, then 4, 2, and then 2. So actually, it looks like what I want to do. Any suggestions here? Because I've got the structure, which is most of the points, but the value is escaping me, right? Sorry? I could do 10 to 1 instead. I could do 10. You're saying to swap these values instead, right? 10. I is equal to 10. Then you're saying maybe to do I minus minus, or minus equals 2, right? Minus equals 2. And then to do what? Let's see. Well, I is greater than 0, right? So you're saying to do this. And now I can just print out I here. So now I'll have 10, 8, 6, 2, 4, 10, 8, 6, 2, 4, 10, 8, 6, 2, 4, 10, 8, 6, 2, 4. But now that just gives us a different problem to solve. So now on the first row I want to start at 10. On the second row I want to start at 8. So I've got 10 here for the first row, so that's fine. Second row I'd like to start at 8. So a way to do that is to do maybe minus 2 times row over here. So it'll be 10 on the first row, 8 on the second, then 6, and 4, then 2. So this one's a tricky one because, of course, it's a descending one. So here, I like this one a lot. What is the output of this loop? Right, and in here, this is where you definitely want to actually not try to, this is basically where you have to turn into the compiler itself and try it yourself. So the way this one is best, works best, is if we write down a value for I, so I is equal to 0, j, a value for j, right? So let's start out. I is equal to 0. Let's continue. Is I less than 3? Yes, it is. So we'll start the loop. J is equal to 0. Okay. Is 0 less than 0? Yes, it is. So the first thing I want to do is print out I plus j. So that means I want to print out 0. And then it says print out a space. Okay? Don't really have to show that you print out a space, but whatever. And then, okay, then increment j to 1. Is 1 less than or equal to 0? No, it's not. 1 is not less than or equal to 0, so we're done with the inner loop. We go to the next line. Okay, and then we increment I because we're done. Right, and j doesn't exist anymore. So 1. Okay, j exists again. It starts at a 0. Is 0 less than 1? Yes, it is. So we do what the loop says, which is to add I and j together. So that's 1. Then add a space, and then increment j. Is 1 less than or equal to 1? Yes, it is. So print out I plus j, which is 2. Awesome. And then increment j to 2. Is 2 less than or equal to 1? No, it's not. So continue on. Okay. So now we've continued. So that inner loop ended. So we do a print line. We go to this third line over here, and then we increment I to 2. Okay, is 2 less than 3? Yes, it is. So we continue on going with this. Okay, j is set to 0. Okay, is 0 less than 2? Yes, it is. So we do 0 plus 2. Increment j. Is 1 less than 2? Yes, it is. So we do 1 plus 2. Is 2 less than or equal to 2? Because that's the condition we're checking. Yes, it is. So we print out 4. Is 3 less than or equal to 2? Nope. So print out a new space. Increment I to 3. Is 3 less than or equal to, sorry, is 3 less than 3? Not less than or equal to. Is 3 less than 3? No, it's not. So we're done with the loop. So we're done with the question. So our answer is 0, 1, 2, 2, 3, 4. All right. The next is some. Okay, so the next questions are the programming equivalent of the shell game, which is essentially look at all the shells underneath. I'm hiding something underneath one of these cups. Follow the cups as I move them around, right? So here it's asking you what are the values of x, y, and z after the following statements. So x is 7, y is 8, z is -5. X is equal to x plus 1. So that means we store 8 in x, right? Y is equal to y plus x, y, and z. So that would be 8, 8, and -5. So 16 minus 5, which is 11. So we store 11 in there. Then we do z plus plus, which is -5. When you increment -5, it doesn't go to -6. It goes to -4, right? It goes up. We add 1 to it. So, right. So basically what this tests is, so if you're wondering what this question tested, it basically was checking two things. One, did you understand that basically once we change 7 to 8, it remained changed to 8 in the next line? And then if we increment it, and that incrementing increments something from -5 to -4. Okay. What is the output when Annoy 534 is called? So here we've got the variables a, b, c, and d. When we pass in 5, 3, 4, and 2, a is 5, 3 is b is 3, c is 4, and d is 2. So is 5 greater than 3? Yes, it is. Is 5 less than or equal to 4? No, it is not. Is 3 greater than, let's see, is 2 greater than, well, 2 is not greater than any of the parameters, so that's going to be false. Or is 2 less than 3? Yes, it is, so we're going to print out green. What about 2, 3, 4, 5? Is 2 greater than 3? No, it is not. So that's false. And actually, don't have to check if A is less than or equal to C anymore, because once I got something false, I can do what's called short circuit. I don't have to, once you know that one part of an AND is false, you don't have to check that the other part of the AND is false, right? Because both of them have to be true in order for them to all to be true. Once a single part is false, you know the entire thing is false. Continuing on to D, we can do something, this part we can do something similar. Is 5 greater than 4? Yes, it is. That's true. One part of this OR statement is true, so the whole thing is true, so this is also green. All right, I personally like this one. So we've got 3 functions, foo, bar, and baz, okay? And I call them each one's in main. Foo prints out foo, bar calls foo, prints out bar, and calls baz. Baz prints out baz and calls foo. All right, so let's go through. So now what's the output? Right, foo, bar, and baz get called once, and it's easiest if we just break this up into individual pieces. Right. So foo gets called first, and all foo does is print out foo. So we write down foo. We call bar next. It prints out foo. So bar calls foo, which prints out foo itself. It prints out bar. And then baz, we call baz. And baz prints out baz as well as foo. Right? Makes sense? You just gotta follow it, right? So what we had here in the first part was just foo, which printed out foo. Bar calls foo, which prints out foo. Then it printed out bar itself. Then we called baz, which printed out baz and called foo, which printed out an additional foo. Now we call baz one more time at the end, which prints out baz and another foo. Okay, so you just got to follow the leader there. So now the reason I like this question isn't just for that, which is annoying, but if we change baz so that what it does, so if we change Boz to the following, that Boz calls bar. If we change it so that Boz calls bar, what happens to the output? So bar calls Boz, and Boz now calls bar. Any idea what happens there? Whoops. So let's go ahead and see what happens. What do your instincts say happens when we change it from so let me go. New class, foo bar Boz. Right? What do your instincts? So, right, this was without the changes. And now when we make this change, scrolling isn't working for some reason, so we add bar to the end of this. What do your instincts say are going to happen now? So bar is going to call Boz, Boz is going to call bar, bar is going to call Boz, Boz is going to call bar, right? What's going to go on? Is there any reason why this should stop? No. So in fact, if you put infinite loop, that would be correct. Technically what we get over here is actually a Stack Overflow error, where basically it means we had too many functions calling functions calling functions. And it just simply said we can't print any more out.
You're not recording the screen like that.
Yeah. Yeah, that's why I cloned it so that so this is what's getting recorded. So if you see this, that's what's being recorded. That way, if I'm recording like this, it comes up here. That way, that's going to avoid any unfortunate accidents in the future. All right, so a couple more program things. So what is the output of this following code? Okay, pass 4, 6, and 8 into this method. Right? Except the method's got y, x, and z there. I guarantee you there's going to be one of these problems on this exam, one of these problems on, this is as close as I get to trick questions. One of these on the exam, one of these on the second exam, one of these on the final exam. There's always one kind of question that's similar to this, where the parameters are given different weird names. So 4, 6, and 8. So x gets incremented once to 7. Y, which is 4, does 4 minus 7 plus 8. 4 minus 7 plus 8, so that would be 4 plus 1, essentially, which means that we store 5 over here. And then print them out in a different order, which would be 8. We said this was 5. Sorry, this was 7, and this was 5. The easiest thing I found to do, actually, is to completely ignore the numbers I give you, right? Sorry, not to completely ignore the numbers I give you, but instead to completely ignore the letters I give you, right? You were given confundus y, x, z, then told to do x plus plus, right? And then do y equals y minus x plus z, and then p print out z, and I'll just do z comma y, z x y, right? Z x y. And honestly, when they're out of order like this, the easiest thing to do is to actually just put them in order, and just give them different variables names. So let's replace all the y's with a's, because now that will make it easier to follow. All the x's with b's, and all the z's with all the y's with a's, all the x's with b's, and all the z's with c's. Well, that looks a bit friendlier. Okay, so now we've got that we were passed in 4, 6, and 8. B++ had to change that value to b's value to 7, right? So 4 minus 7, so that was -3 plus 8, which is 5. So now a is 5, and now it wants them out, and it wants CBA, so that's reverse. So 8, 7, 5, right? So just by giving him variables, it became new variables, and giving the variables in order, basically it took out that single step, a deliberate step of confusion that I added. Okay. So write a method called each character, which returns a new string made by separating each character with a comma and a space. So hello becomes H, comma, E, comma, O, comma, L, comma, L, O. So this is that fence posting problem I mentioned once. So again, with these things, you want to get them as close to correct as possible, which is, well, I don't know how to trim off this last bit, okay? Like, right, the tricky part here, like, it's not too, so let's just, like, work on, like, making a method where it says to return a new string made by separating each comma character with a comma space. So we're just going to build this incrementally. Right, and I give you the method header, public static string each character. So I know this needs to return a string because I told you to do so, right? So let's go ahead and make a string to output. Equals the empty string, and then output, right? Okay, then what I need to do is that I need to add, well, I need to go through each character and then add it to output as long with a character in a space. So for int I is equal to 0. So how do I go through a string like that? For int I is equal to 0. I is less than str.length, right, to go through all the indices of the string. I plus plus. Okay. And then output is equal to plus equals output. Sorry, output is equal to the output we currently have concatenated with that particular character. str.char at I. Now this would just simply give me, if I typed in hello, this would give me hello, right? It won't give me hello, comma space, with comma and spaces between each characters. But that's not hard to add, right? All I have to do is to add that is to literally add, comma, space. And now if I put in hello, I'll get H, comma, space, E, comma, space, L, comma, space, L, comma, space, O, comma, space. So aside from this last comma space, right, I'm good. Right? Aside from this last comma space, I'm good. And this question's worth 10 points. And in my book, at least, getting it close to this is worth 7. Right? It's worth 7 out of the 10 for not getting that last one out. So there's a couple different solutions to getting this to the full 10. The first that was pointed out to me is to use a substring operation. You want everything but the last two characters. Okay? So 0 through, well, if I put in string.length over here, that goes up to the last character. This doesn't include the last character, so this won't include the last two characters if I go length -2. So that's one way to do that if you're comfortable with using substrings. The other way to do that is to manipulate your loop, which is instead of adding everything but the last character is the problem, right? We do everything before the last character, so we do a -1 over here. And then we return output plus the very last character. So str.char@. And what's the last character call? Well, it's the last character is located at str.length -1. So there's a couple other ways. So there's, as you can see, there's multiple solutions, right, to go from the 7-point answer, which I showed you, which has the common space over here, to the 10-point answer. One of the questions on the exam will have a alternate solution where basically you can where I say if you can get to this point, it's half credit. Okay. Write a new method called sum of threes, which returns the sum of the first n positive integers that are divisible by 3. If n is less than or equal to 0, return 0. So if we input 3, we get 18 because the first n integers that are divisible by 3 are 3, 6, and 9. If we put in 5, we want 45 back because the first 5 integers are 3, 6, 9, 12, 15. And we add them all together. So this is a running sum. Okay, so how do we, what do we put in here? So how do we do this one? It's not so bad to do this one. Again, I tell you to return it. I give you an int to return an int. So first thing is to handle our return statement. So int sum is equal to 0. Return the sum when we're done with this, right? And then we need to return basically the first 3. We need a bunch of numbers that are, we want integers that are divisible by 3. The first n integers that are divisible by 3. So we want to do n numbers. Okay? For int I is equal to 0, I is less than n to get n numbers, I++. So we'll get I numbers this way. And then if we do sum equals sum plus 3i, well, that gets us close to the answer. It'll be 0 times 3, then 1 times 3, then 2. If I put in 3 here, I won't get 18. I'll get 9 because it'll give me 0 plus 3 plus 6 because we started at 0. But still, that's pretty close. Again, a minor mistake there. But if I switch it to this one so that it's 1 through n, now it'll be 1, 3, and sorry, it'll be 1, 2, and 3, which will be 3, 6, and 9. Everybody see how that works out? So I start by basically trying to get as close to the answer as possible, and then I adjust my answer, based on what I need. Oh, and if I get -1, this loop won't run, right? If I put in -1, this loop won't. We start at 1, while 1 is less than or equal to -1. So the added benefit is that it takes care of the not having to write an if statement there. This last one's fairly straightforward to do, and I think you guys are more than capable of doing it yourself. Okay. In the main function provided, write a program that asks the user to input an integer, right? So you've done this, and then keep asking until the user enters 13. Once 13 is entered, the program outputs a sum of all the integers entered. It includes the 13, and you can assume the user will follow directions. You can assume scanner is imported. This one's fairly easy. I don't really see a need to go over it in class. It's fairly straightforward because all this is you create a new scanner from system.in, and then you create an integer called you create an integer called input and an integer called sum, which is equal to 0. And then you ask the user to and then you say, while your input is not equal to 13, read in a number and add it. Read in input, then add it to sum. And if that number that you read in, and then the while loop checks if that number is equal to 13. So I kind of just described the answer there. All right, so additional practice, right? Write a nested loop that prints out these statements. And I think for the rest of the for this session, I want to go ahead and just see where you all are on your program, on your homework, and then I'll help you with your and I'll help each of you for the last remaining 45 minutes on your current homework. And I want to see where you are.